Hi, my name is Nick Borson, and in this video, I'm going to explain how you can use PowerShell to create your own classes. A class is a type of object that you define, and um, based on how you create the class determines what properties and methods the object has. So to start with, I'm going to use a series of demos that build on each other. In the first demo, I'm not actually going to use any classes at all, but I'm going to use some of the same concepts that I talked about in a previous video about PowerShell hash tables. So in this first script, pardon me, in this first script, we create a hash table that contains a bunch of elements, each of which contains information about the population data for a state. So the input I'm using for this script is a CSV file, which looks like this. A CSV file is like a spreadsheet, but it's just a simple textual representation of a spreadsheet. And I created this one by extracting some population data from the U.S. Census Bureau. So the first line of the file contains the column headers, and each subsequent line contains one record. So, for example, the first record has the name United States, the population, whatever that is, and then births and deaths are these two values, and likewise for each of the other lines. So when we read this file, in the script, I start by first creating the path of the file. So I take the PS script root, which is a predefined variable that is always the directory that contains the script in which this appears. So anytime you have a PowerShell script and you use the variable PS script root, that refers to the directory containing the script. So then using join path, we combine PS script root with the name of the file, and we get the full path of the CSV file that we're reading. So passing that as an argument to get content, we then get content then returns the contents of that file, which is just an array of strings, one string for each line of the file. We then pipe that to the convert from CSV PowerShell command. This is a very handy little PowerShell commandlet that converts CSVs from just plain text into a convenient into a series of objects, which has already been parsed so that all of the fields are exposed as properties. So again, going back to our CSV file here, the convert from CSV uses the first line of the file, which is assumed to be a header row, to determine the names of the properties. Then the first object that it returns is an object that contains four properties: name, United States, population 331 something million, births 894,000, etc. So going back to our script, now we have a series of objects with those properties. Then we pipe that to the for each object command, and that executes this script block inside the curly braces once for each object that is passed to it. So once for each record in that CSV file. And within that script block, the $underscore pipeline variable, which is again kind of a magic variable name, that takes on that is associated with that variable is then bound to whatever the current object is for the current record in this case from the CSV file. So here we get to the meat of what we are doing in this script. We're building up a hash table that contains one object or one element for each record in that CSV file. So we start by creating an empty hash table. So before we even enter this loop, we create we initialize the variable pop by state to an empty hash table. So that's using this @ curly brace syntax. And because there's nothing inside these curly braces, the hash table doesn't have any elements yet. But the curly braces tell PowerShell that this is, in fact, a hash table, an empty one. And then we can add elements as we go. So that's very important, because if we hadn't created the hash table ahead of time, then when we executed this command, PowerShell would say pop by state is a null object. I can't invoke these square brackets or this array operator on it. But since pop by state is a hash table, this array operator will look up we'll look up a record in that hash table corresponding to that name. It might help. Again, I would refer you back to my earlier video on PowerShell hash tables. But just to summarize, a hash table is a type of container, is a collection of name-value pairs. So each record has a name and a value, and you refer to elements in the hash table by name. So unlike an array, where you refer to elements by position, where it's a sequence of elements and you refer to them by their numeric index in that sequence, in a hash table, the order of the elements isn't important. What's important is that each element has a name, and or it doesn't even have to be a string. It doesn't have to be a name per se, but it's a key of some kind. And you look up an element. You look up a value by referring to it using its associated name. So, for example, you want to look up the population of Texas. You pass Texas as the name to you look up using Texas. You don't have to search the whole hash table until you find one that's called Texas. You just look up Texas and you get that result. So here what we're doing is we are assigning to a member of the hash table with this name. We're assigning it a new object, which is in this case a new hash table. So this is, again, following what I did in that PowerShell hash tables video. I'm creating another hash table, a tiny little hash table that just has 3 name-value pairs in it. One for each of the properties, and I'm using properties in scare quotes because we're not really creating a proper class type that has 3 properties. We're creating a hash table that has 3 entries with the names of, and the names of those records are the properties that are the kind of pseudo properties that we're interested in having: population, births, and deaths. So we create a populations record and we assign it the value of the population, and a births record, assign it the value of the births, and a deaths record, and assign it the value of the deaths. And at the end of all that, what we have is a big hash table of hash tables. So each entry in the top level hash table is itself a little hash table with 3 records in it. And at the end, just to make sure it works, we can just look up the record for Texas and see what the output of that is. So let's go ahead and do that. Demo 0 is the script we just looked at. And if we invoke that, we get the record for Texas. Texas's births are 88,000 something, its population, whatever that is, and deaths is 55,732. So that is our first script. But so far we didn't create any classes. And that's where we get to the next video. We're going to change how we do this part right here. So let's take a look at demo 1. So demo 1, we read the CSV file in exactly the same way. We convert it from CSV to a sequence of objects, and then we execute once for each object. But then inside likewise, we've created this top level hash table. But instead of adding a nested hash table for each record, we instead define a class. And this class we just call it pop data for population data, and it has 3 properties. So we use this syntax to define a property. We simply have the type in square brackets, and then we have the name of the property preceded by a $, just like variable names are preceded by $signs in PowerShell. So that's all we've done. That's all we had to do to create a prop data class with 3 integer properties. And because those properties are declared as having an int type, that means they can only be integers. They can only be numeric values, positive or negative, or 0, and they can't be fractional values. They have to be an integer. They can't be a string. Or if you try to assign a string or something that's not, and that can't be converted to an integer, to one of these, you'll get an error. So you have a distinct type. So here we create our top level hash table as before. We execute our code block, and now each item in the hash table is going to be an instance of our pop data class. So to create the pop data class, we use the new object commandlet, and we specify the type name pop data because that's the name of the class we created. And then the result of that is a pop data object, which we've assigned to this $pop variable. Once we've done that, we then just initialize each of those 3 properties we've defined to the values from the pipeline object. So again, coming from the CSV, we have the $_ population. We assign that to our new to the population property of our new object, and likewise for births and deaths. And then at the end, we then store that in our hash table by referring to the referring to the element of the hash table with the name, whatever the state name is, and assigning that, storing in that element the new object we just created. And at the end of all this, after we've built up our whole hash table, we're just going to look up the element for Texas again, just to see that it works the way we expect. So let's go back to our script, and now we'll do demo 1. And you'll see that it looks a little bit different. The values are the same. We have population, births, and deaths, but it's just formatted differently. And the reason for that is because this is a hash table, and when you output a hash table formatted as a table, what you get is 2 columns, a name column and a value column. And that's because each of these is a separate object in the hash table, and each of those objects has a name and a value. So each of these objects is a name-value pair. In this case, what we have is one object with three properties. And so when we format that as a table, then each of those properties is a column. And if we had multiple objects here, we'd actually just get multiple rows with these column headers. If we format these as a list instead of a table, you can see that they're also different. If we do demo 0 and say format list, then here's the hash table. We have the first object has a name property and a value property. So again, the hash, it's not just one object, it's a hash table with 3 elements in it. The first element has a name, births, and a value associated with it. The second hash table has a name, population, and a value, and the third hash table has a name, deaths, and a value. So it's 3 name-value pairs. And if we do demo 1, formatting this object as a list, we get more of the familiar formatting you get for a typical object, where each property has an associated value. Okay, so it's a little bit more, if what we want is to have objects with properties, using a class to do that is a neater way to do it than using a hash table. So what more can we do with this? So far we've created a class, and the class has properties, but we can do more with classes. So let's look at our next demo here. So in this case, I've created a little bit more complicated class. It's still called popData. We still have our properties, but in addition, we have a constructor and we have a method that returns an integer. So the constructor is like a method, a function that you can call on an instance of the class, but it's a special method because it's a method that is used to initialize a new instance of the class. So when you create a new object of this type, the constructor is automatically invoked to initialize the object, to set its initial values or do whatever other processing needs to happen in order to make that into a valid object. Now you can have what's called a default constructor with no arguments. You would still need these parentheses, but you would not have any parameters inside them. Or you can have constructors that have arguments, as in this case. Or you can have both. You can have multiple constructors. So in this case, we have a constructor with 3 arguments, which are the 3 values we want to specify when creating the object, and the constructor simply stores those values, initializes, simply assigns those values to the corresponding properties. So we use the this keyword to refer to members of this instance of this object. When you're invoking a constructor, the this object is the object you're constructing. So this.population will be setting the population property to the parameter that was passed to the constructor. And likewise, here we're setting this.births, the births property of this object, to the births parameter that was just passed in, and likewise for deaths. So we'll come back to the other method in a minute. Let's go down a little farther, and we can look at how we're initializing our popData objects. So just as before, we create an empty hash table, pop by state, and just as before, we read our CSV file, convert it from CSV to a sequence of objects, and then for each object, we invoked the script block. Then, within that script block, we're creating our new popData object in just one step. So we use the new object command, and again we specify the type name pop data, but now we have something new. We have this argument list. The argument list is the sequence of arguments that get passed to the constructor. So if I scroll right here, you can see we're passing the population, comma, $_population is the population object from the CSV object, population property from the CSV object, comma, $_births is the births property from the CSV object, and likewise deaths. And so these three arguments then get passed as the arguments to the constructor. It's important to include these commas. Essentially this, when you include commas, this sequence, the things are treated as a single array. And I could put those if I wanted to. I could say array. I could use the array syntax like so. But the commas by themselves serve the same purpose. Just depends on whether you want to be explicit about the array syntax. So this will construct this new object, invoke the constructor to initialize the properties, and then the result of that new object command is this fully initialized object, which we then store in the hash table as before. So having the constructor allows us to do that all in one step, which makes the usage of the class a little bit more convenient. Now in this script, I've also, instead of just outputting the value for Texas, I got a little bit fancier, and we have here an interactive loop where we ask the user to enter the name of a state, and then we output the properties for that state. So this is to demonstrate another method here, which is another thing of the class, which is we've defined a method called netBirths. So this is like a function that you can invoke on the class, just like a lot of anyway, so when you have an instance of pop data, you can call the netBirths method on that instance, and it will compute the difference between births and deaths and return that as the result. So unlike defining a function, typically defining a top-level function in PowerShell, you use the function keyword. To define a method, it's a little different syntax. Instead, you start by specifying the return type of the method, which has to be enclosed in square brackets. In this case, the method returns an integer. Then you give the name of the method, and then you include parentheses. And if the method takes parameters, then you would include those as well, just like we did for the constructor. But those would happen within the parentheses. But even if you have no parameters, you have to put the parentheses here, because that is what tells PowerShell that this is a method and not a property. The parentheses are then followed by the curly braces, which is the code block, which is the actual implementation of the function. So in this case, the implementation of the function is simply to subtract the deaths from the births. Again, we refer to properties of the object that this method has been invoked on using the this sort of built-in variable. And the result of this has to be returned using the return keyword. So again, that's a difference from a normal PowerShell commandlet. In a function, you actually have to use the explicit return keyword if you're returning a value. If you don't return a value, you can have methods that just do some operation but don't return anything. In that case, the return type would be void. But if you're returning a value, you have to have a return statement, and the return statement has to return something that matches the return type that you specified. Okay, so how am I using that here? Well, here's our interactively processing the user input. We have a loop. It's a while loop, so the body of this loop will execute as long as the condition here is true. Since the condition is always true, this loop is going to execute indefinitely until we break out of it. So for each iteration of the loop, we just write a blank line, and then we use the read host command to read to prompt the user for input. So we'll tell the user enter a state. That's the prompt argument here. And when the user types something, that gets returned and hits enter. That gets returned back and stored and returned as the result of that command, which in this case means we're storing it in the name variable. So name is now a string, which is whatever the user typed. If the user just hit enter without typing anything, that string will be an empty string and will break out of the loop. So that's what this first condition is. That's the first option. This is the only way we exit this loop. Otherwise, we then look to see if our hash table, pop by state, contains the key, if we call it contains key method, to see if that hash table has a record with the name, whatever name is, whatever the user typed. If it does, then we're going to enter this else if block. Otherwise, we're going to follow through and execute the else block. So this is the case where the name was not found, and that's exactly what we say. We write to the host, name is not found. But if we did find the name in the hash table, if the hash table did have that key, then we actually use the array operator to get the object associated with that key, the pop. This is the pop data object that we defined, and we write output. Actually, we could probably say write. Since we're doing this kind of interactive thing, we could probably say write host here would be more appropriate. And we write the population is, and then we refer to the here we're referring to the population property of this object. And here we're invoking the net births method on that object and getting its result. So let's take a little closer look at these two lines. So just to remind you, this is the way string interpolation works in PowerShell. If you want to insert an expression into a string, you can wrap the whole expression in $, left parenthesis, right parenthesis. So this whole thing here, everything inside those outer parentheses is an expression that gets evaluated. And then whatever the value of that expression is gets converted to a string and inserted in place of that whole, of what I've selected. So the expression in this case is $pop.population. So it's getting the population property from that object. And here, again, we have $ parentheses. So the contents of those parentheses are evaluated. So here we have $pop.netBirths parentheses. So netBirths is a method that we're invoking. So we'll invoke that netBirths method. It will return a value, and that value will then be inserted in place of this whole thing. So let's say netBirths : whatever the result of that function is. Okay, so let's go ahead and run this. So demo 2, and it's asking us to enter a state. I'm going to say Alaska, and it gives us the population and the net births. So again, the difference between the births and the deaths. If I say, and now if we go back to here, while true is always true, so we've fallen through to here, we go back and execute the loop again, write a blank line, again enter the prompt. So we're going to say, let's try another state. We'll say Texas. And again, we have the population and the net births, which in this case would be the births minus the deaths. Like here we had the births and deaths up here. So it's that top number minus the bottom number. We are net births. Let's try another state, New York. And here we have a negative net birth. So apparently in this time period, in that year, New York had more deaths than births. So we have negative net births. Then if we hit enter, we fall out of the loop. Oh, and I guess I didn't demonstrate that what happens if we enter a state that wasn't found in the hash table. It would be, if I say the state of confusion, then it says confusion not found, which seems kind of appropriate. Okay, so that's this version. By the way, you might wonder why write output. What's the difference between write output and write host? Well, host is like if you're interacting with the user. So host is like the console. We always read, if we're reading from the host, we're actually interacting with the user and having the user type something. If we're writing to the host, we're writing directly to the console. Writing output might have the same effect, but the output could also be what gets returned by the function to whatever calls the function. So it could be writing to the pipeline. If the result of a function is assigned to a variable, for example, writing output would go into that variable. Write host always goes to the console. Okay, so that's demo 2. So those are so we had 3 versions of the three scripts that essentially did almost the same thing. We read this population data, we create a hash table of objects, but in the first case, the hash table contained used little mini hash tables to represent each of the states. In the second case, we had we created a simple class that just had 3 properties, and in the third case, we we created a little more complicated class that had 3 properties, but also had a constructor and also had a method to compute a value for us. Now let's go to a completely different example that again is using classes, but for a different purpose. And we're going to demonstrate some new concepts here. So there are 2 things that this demonstration is going to show. One is the concept of inheritance, and one is the concept of building up a tree of objects. So in this, what we're doing is we're taking a mathematical expression. So let's, in this case, we're just taking the expression 1.5 times 10 to the third. So you can think of an expression like this as a tree, just like when you diagram a sentence or something, using grammar, you can have, you can build up, you may have sort of seen that done where you have like a sentence consists of a noun phrase and a noun and a verb, and the verb phrase might consist of other things. So you can diagram into a tree. Likewise, for a mathematical expression, it's actually much simpler to do this. In this case, we have the major operator of this whole thing is the multiplication. So we have a product of two things. On the left-hand side of the product, we have the constant 1.5. On the right-hand side of the product, we have 10 to the third. So that in turn is also an expression in its own right. It's a power expression where the base is 10 and the exponent is 3. So we have 1.5 times the expression 10 to the third. So so the power 10 to the third is the right-hand operator of the product, and 1.5, the constant 1.5, is the left-hand operator of the product, and so on. So how do we express this in terms? So we can think of this not just as a tree conceptually, but we can actually build a literal tree of objects to represent this. And each of these objects is an expression. So here we have our expression type. The expression type now is just the base class. It's like it just represents an abstraction of any kind of expression. There are multiple kinds of expressions. Some of them we saw that there is a constant. We saw that there's multiplication or power. We saw that there's product or power. So in this example, we have really 3 kinds of expressions. But the class expression is really just this abstract base class that's common to all of them. And all it really does is it defines a method called eval. And we don't actually use the method on the base class. It just has to exist because we're saying that every expression has to be able to evaluate and give you some number in return. The number in this case is a double. Double means double precision floating point number. So it's a number that can, it can be 1.5. It can be a fractional number. That's what floating point means. And double precision is just that's the usual kind you'll typically use when you're using floating point numbers, because it's the most, it can have the most precision and the largest values of sort of the built-in capabilities of most computers. So anyway, so we have a method called eval. On the expression base class, we don't really use it, so we just return 0. Now here we have another class called constant. And so the constant class, we see that we have class constant, and then we have something new. We have :expr. That means that the constant class is based on or derives from the expr class, the expression class. So expression is the base class and constant is the derived class. And what that means conceptually is that a constant is a kind of expression. Constant, it has an is-a relationship. A constant is an expression. And for that reason, a constant also has to have an eval method. And in the case of the constant, all the eval method does is returns the constant value. It returns the value of that constant. So the constant object the constant class has a value property, and the eval method just returns that property. So here we are. And we see that we're just defining methods just like we've seen before in our previous example. And then here I've defined for convenience, I've defined a helper function to create a constant. It's just called new constant. And it takes the value that you want that constant to have. It calls new object to create that constant, assigns the value property, and returns the object. Okay, so here's another expression type. So here we have another class for another kind of expression. So a product is not a constant, it's a different type, but it is also an expression. It's a kind of expression. So we have class product. We specify that it has the expression as its base class. So a product is an expression. And a product has two other expressions as properties. So it's a product of two things. It's not necessarily a product of two constants. It could be a product of any arbitrary expression on the left side and any arbitrary expression on the right side. That's how we're able to build up this whole tree to represent any expression we want. And then when we evaluate the product, what we do is we call eval on the left expression. So you see we're invoking a method. So this, again, is referring, so this.left is giving us the left property of the product object. We're invoking eval on it to compute the value of that expression, whatever that may entail. And then we do the same thing for the right-hand expression, right-hand sub-expression. We multiply those two things together, and the product of those, the result of that multiplication is the product. So that's what we return. And likewise, we've just as a convenience, created a helper function, new product, to create a product object given two expressions. So we pass the left-hand expression, the right-hand expression, and again, we've declared the types that were passed in. We just expect there to be an expression passed in. And we new up the object, we assign the left and right properties, and we return the object. So it's very simple. And then power is very similar to product. We have power. The power class derives from the expression class. It has left and right properties, each of which is an expression in its own right. And the eval method invokes the eval method of the left expression, invokes the eval method of the right expression, and passes both of those as arguments to the pow function, the math, which is a static function on the math class. So that's why we use this syntax. So this is referring to the math class, which is built into the .NET. We invoke its static pow method, and we pass these two arguments, the left and right, the values, or the result of evaluating the left and right expression. And again, we have a helper function to create a power object given two expressions. So how do we use this? Well, again, let's look at our, this again is the mathematical expression we want to evaluate, 1.5 times 10 to the third. This is how we can think of that as a tree. We have a product object, which is again a type of expression, but it's a specific type of expression. And then it has a left argument, which is a 1.5 constant, and it has a right argument, which is another expression, in this case, a power expression. Because of that is a relationship, if you have a power object, you're able to assign it to an expression variable because a power is an expression. So the power object in turn has left and right sub-expressions. The left sub-expression is a constant with value 10, and the right expression is a constant with value 3. So we can build that whole thing up by using our little helper functions. So let's kind of look from the inside out here. So we create a new constant 10. That will be the left argument of our power object. We have a new constant 3. That will be the right argument of our power object. And then we have new power passing those two things. So this whole, what I've selected here is creating a power object with a left constant with a constant 10 as its left argument and a constant 3 as its right argument. Then that whole thing is the second argument, is the right-hand argument that's passed to new product. So new product has new constant 1.5 as its left argument. So this is going to give us an expression object, and specifically a constant object that has the value 1.5. And then the right argument to new product is going to be this whole power object. And at the end of that, we have a top-level object that is the whole expression, which in this case actually is a power object. Or excuse me, a product object. So the relationship of these objects is a kind of tree where you have objects that point to other objects or refer to other objects. And in that way you can build up all kinds of complicated structures. Then when we call eval on this top-level expression object, it's going to be this top-level object happens to be a product object, so it's going to call the product object's method. So again, what does that do? It's going to evaluate its left operand, and it's going to evaluate its right operand, and it's going to multiply those two things together. So here we are. We evaluate the left operand. The left operand again was this 1.5 constant. So evaluating the left operand is just going to return 1.5. Then evaluating the right operand is going to call the eval method on the power object. Well, what that's going to do is evaluate its left operand, which is again a constant, it's just going to return 10. And it's going to evaluate its right operand, which again is a constant, just returns 3. And then it's going to take the 10 and the 3, call math.pow, or math.pow on that, as we see up here. So it's going to take math.pow 10 to the third, and it's going to give us 10 to the third, which is 1,000. So now we have eval of power has returned 1,000. Eval of this constant has given us 1.5. So product then is going to multiply those two numbers. So you'll have 1.5 times 1,000, which will be 1,500. So we should have 1,500 as the result of evaluating that whole thing. So let's try it out and see what happens. Demo 3. And there's an example of something where the output is not that exciting, 1,500, but it is what we expect from this whole thing. So to summarize what we've learned from this whole exercise, you can use classes to simply define simple structures or records that have properties, and you can store those in hash tables or organize them any way you want. You can simplify the creation of your own classes by creating constructors, and that allows you to create and initialize objects in one step. And the constructors can do whatever. In this case, the constructor is simply storing property values, but the constructor could do whatever you want, any logic you want, in order to put that object in a valid state. You can define methods on objects, in this case the netBirths method, and those methods can return values. And finally, you can create classes that derive from other classes, as the constant class derives from expression, as the product class derives from expression, and you can also create objects that refer to other objects, as the product class refers to other classes, it refers to other expression objects as its left and right arguments. And in that way you can build up structures or graphs, arrangements of objects that are all linked together into a tree structure or some other structure that represents concepts in your program. So I hope that helps you to understand how classes work in PowerShell. And the classes are a common feature of programming across many different languages. It's a fundamental piece of object-oriented programming, which is common to many languages. And it's great that PowerShell has this capability as well. Hope you enjoyed that and find classes useful. Thank you.